Welcome to lesson number 3 on quadratic and linear systems and inequalities. So today we're going to be focusing on inequalities, and this is something that should be really familiar to you. You know, you're working with situations where you have an equation, and within that equation you have an inequality sign that's either greater than, equal to, less than equal to, or not equal to. Okay, so using these different signs, sometimes in a single variable, sometimes with two variables, you're gonna describe well basically where an x value lies within these parameters here. Okay, so below here is an example where we have a single variable involved. So the variable in this case is going to be x, and in this case would be a. Now the solution to a single variable inequality can be shown on a number line. Right, so you've all seen number lines, and we'll look at an example pretty soon here, which will and where we'll use a number line. So let's just jump to this example. So consider the inequality 4 minus 2 times 3 plus x is greater than 12. So to solve this inequality algebraically, this is something that you've done before when you're looking for the domain or range or restrictions on certain equations. All right, so 4 minus 2 times 3 plus x is greater than 12. So my inequality sign here is telling me that my left-hand side of my equation is greater than my right-hand side equation. So this side is greater than 12. If I expand these terms in the middle, I'm going to be left with 4 minus 6 minus 2x. All I did was FOIL this and distribute the 2 inside my brackets, and I know that that is greater than 12. Now I need to simplify, and I'll bring my 4 minus 6 is going to be negative 2, bring that to the other side, negative 2 plus 2 to both sides. I'll be left with negative 2x is greater than 14. Now I need to solve this by balancing out my equation and solving for x. So I'm going to have to divide by negative 2. So when I divide by negative 2 on both sides, remember if I'm dividing by a negative across my inequality sign, that's going to end up flipping my inequality so it faces the other way. So what I'm going to be left with is x is less than negative 7. All right, so x is less than negative 7. Now we want to check the solution using a test case. So when you're choosing a test case, you want to choose a value. We want to choose a value of x that is going to fit within these parameters. So I want to choose a value of x that is less than 7. So choose a value of x which is less than negative 7. Now, the reason I'm choosing a value that is less than negative 7 is because I'm told that in my inequality that I solved algebraically up top here, that x was less than negative 7. And so let's just try, we'll try something like, let's try x is equal to negative 10, since that's less than negative 7. So we need to plug into our left side, right side. So just like we did a couple units ago, left side and right side. All right, so the left side of my equation was 4 minus 2, 3 plus x. And so if I plug in negative 10 there, 4 minus 2, 3 plus negative 10, we're going to get 4 minus 6 plus 20, if I expand that, and that is equal to 18. All right, so if I plug that into my equality, that's telling me that 18 must be greater than 12, right? Because my original equality was up here, 4 minus 2, 3 plus x. So if I plug in negative 10 for x, I'm going to get an answer of 18. And so my left side had to be greater than my right side, and in this case, my left side is going to be 18, whereas my right side was 12. right side is equal to 12, that means that left side is greater than the right side, and so negative 10 is in the correct interval. Now we can show this solution on a number line. If I have my number line here, then we were told that our solution to this problem was right here. X is less than negative 7. So on our number line, we could choose a point. We'll just say that this point here is negative 7, and we'll call this side over here X. Now, since X is less than negative 7, then I need to draw my line going this way. All right, so when you're drawing your solutions for inequalities using a number line, we always do it in this style here. Now, this circle will change depending on your sign you are using. And so in this case, I'm just using a x is less than sign. But if I was using one of my above signs up here, that's going to change the style of dot I use. So you'll see on my number line I use an open dot. That open dot is used with your greater than or less than signs. Okay, so if we were expressing this as a number line, I would use an open dot here and an open dot here. When we have greater than or equal to or less than or equal to, then we use one of these. We use a closed dot. All right, so let's try the next example on the next page. Now, I know this looks really wordy, but I think it is very important that you go through, take the time and read what it says in this section, because this is going to help you with the next step of graphing inequalities. So the next thing we're going to look at is linear equalities in two variables. So if I look at these two equations I'm given, I have an x and a y I'm now working with, or a p and a q. So those are the two different variables that are embedded within my equation. Now, when we're solving linear equalities with two variables, then we want to use what's called a boundary line. And we're also going to shade one side of the line, and that's going to represent where the solutions are to these inequalities. All right, so by shading and drawing in a boundary line, that'll tell you where we have values of x that can or cannot exist. So the boundary line will be solid or broken according to the following rule. So I'm reading this section here now. A solid boundary line is used to represent less than or equal to or greater than or equal to. All right, so if you have something like this, less than or equal to or greater than or equal to, use a solid boundary line. One way you can remember that is there's already a solid line underneath each of these signs. Okay, so remember, solid boundary line goes with the greater than or equal to or less than or equal to. Now if it's just greater than or equal to, or greater than or less than, like this, then you are going to use a broken or a dotted boundary line, and I'll show you what these look like in the next example here. Okay, so let's look at this next example. And these are the rules we're going to follow when graphing. So I want to coordinate plane graph the corresponding linear equation using a table of values, intercepts, or point and slope. Okay, so we could use either one of these. We could use our table of values, we could use an intercept, point and slope, or linear equation. Then we want to draw the line of our equation either broken or solid, depending on, remember, depending on which kind of inequality it is. All right, and then I'm going to read the second part after I graph it. So let's look at this first example where y is greater than x. So since y is greater than x, remember it's not greater than or equal to in this case, so we're not going to have a solid line, we know that much. But if y is greater than or equal to x, then remember that if my equation where y equals x, and this is how we're going to graph them, we're just graphing them how we normally would, based on a linear equation. So if y is equal to x, then my line is going to look something like this. Right? Because when y is equal to x, then the slope is going to be a slope of 1. So it's going to rise by 1 and run by 1. And my y-intercept is going to be at my origin of 0 and 0. Okay? So since y is greater than x, then my line is going to be broken or dotted like this. So I usually choose just dashes for a broken line. You could use a dotted line as well. Okay, so this is the first part of solving these questions graphically. The second part, let's read through here. The line divides the coordinate plane into two regions. All right, so we have these two regions, here and here, and these are called half planes. All right, so each of these regions are called half planes. So I have a half plane here, and I have a half plane down here. The solution region will be on one side of the line. So either this side of this half plane or this side of this half plane will be where my solution will lie. To determine which side, choose the coordinates of a point not on the line. So we can choose any coordinate that is not on this line, and we are going to call that a test point. All right, so using a test point, we need to graph what this is going to look like, or where that test point would be, and then we want to determine if the coordinates of the point satisfy the inequality. So if the equation is satisfied, then the solution is the region from which the point was chosen. If not, then the solution region is the other region. And then we want to shade the appropriate region. So we want to shade where we actually have our points. All right. So let's try this first one using a test point. So I'm just gonna choose a test point at 5 and 0. Okay, because you could choose either one. You could choose 5 or 0 or -5 and 0. Now, if I use, so I'm going to use test point 5 and 0. Now, this 5 will be my x value, and this 0 will be my y value. All right, so I'll plug these into my original equation, which is y is equal to x, or in this case, y is greater than x. Now, I'll plug in my value of y, which is 0, and my value of x, which is 5. Okay, so is 0 greater than 5? Well, obviously not. So this is not true. This is not in my shaded region, so no. So we're going to shade the region that does not contain this point here. So when we're shading, all you really need to do is draw lines like this. Or you can shade the entire side, but you could just do these lines. Now this is telling you that everything that my solution is not on this side where 5 and 0 is. My solution lies on the other side of the line. Now let's look at this next example. 3x minus 2y is less than or equal to -6. Now we could graph the line 3x minus 2y is equal to -6, in which case we are going to have to switch our line around, or switch this information around, so we can actually put this on a graph. So if I were to graph this, then I would have to rearrange this completely. So I want this to be in the form y equals mx plus b. That way I'll be able to know what my slope is and what my y-intercept is. So -2y is equal to -3x minus 6. I want to divide everything by -2. When I do that, that's going to be y is equal to 3 over 2x plus 3. All right, so that gives me an x-intercept. It looks like at 2, or a y-intercept. Let's start with our y-intercept at +3, right? That's my b value. So I know that my graph is going to start at +3, and if I have a slope of 3 halves, then that means that I would I would go up 3 and over 2. Or I could go down 3 and this way too. So 1, 2, 3, and 2. So my x-intercept is going to be at -2. All right, so also notice that my inequality is less than or equal to. And so if we have an inequality sign that's less than or equal to, then we draw this as a straight line. And I'm just going to draw another point just so I don't have this crooked. So 1, 2, 3, 1, 2, and 1, 2, 3, 1, 2. All right, so this is going to look something like this, and it's going to go straight down. Now we want to do the same thing. We have our line. Now the next thing we want to do is input our test points. Okay, so we're choosing something, we're using test points that are not on the graph. Now if our graph, in the last example, our graph went through the origin. If your graph doesn't go through the origin like this one, so if your line is going up like this, over here, down here, over here, in any case, if it doesn't go through the origin, the easiest test point to use is the origin itself. So we're going to use, in this case, use test point 0 and 0. And now we plug those in for x and y values. So if I have 3 times 0 minus 2 times 0, is that going to be less than or equal to 6? Well, 3 times 0 is 0, negative 2 times 0 is 0, 0 is less than or equal to -6. And the answer there is no, so we are going to shade our other region. Okay, so. Oh, and by the way, is 0 less than or equal to -6? The answer was no, because -6 is less than 0, right? And so that's why I shaded this side, because the solution does not lie on this test point. All right, let's do the last couple examples. Now all these we're graphing without our graphing calculator. So if I have y is less than 3/4 x plus 3, then I know that my line is going to start at my y-intercept, which is this 3. And I have a slope of 3/4 x, and so that means I go down 3 and over to the left 4, and then I go up 3 and over to the right 4 as well. But I will just draw, and we have a less than sign, so it's going to be a dotted line, and then we need to choose a test point. Again, we're not going through the origin, so we can choose a test point of 0 and 0. So use test point at 0 and 0. Now we plug these in for our x and y's. 3/4 times 0 plus 3, and we're left with 0 and 3. And this is in our test region. So in this case, if you end up with something that is in your test region, or that's on your test point, then yes, that is a solution. Your test point's a solution, and you would shade the area where your test point was. All right, so the other ones, we didn't have our test point in our shaded region, so we shaded the opposite sides because we knew that our solution laid in the other boundaries. So let's look at this quick note over here. If the boundary line is given in the form y is equal to mx plus b, like we looked at our last 3 examples, then the region above the line represents y is greater than mx plus b. The region below the line represents y is less than mx plus b, just like it did in this case here. And the other ones, it was the opposite. It followed this rule here. And again, if the boundary line does not pass through the origin, the simplest test point to choose is 0, 0. All right, so last question. The diagram shows the solution, or the diagram shows the solution region to an inequality. So we know that our solution region is over here. is over on this side, and the boundary line has intercepts at -2 and 0 and 0 and 4. So determine the equation of the boundary line. So all we want to do is find out what this equation is. Now we are given 2 points, which means we can find our slope. Remember, slope is equal to y2 minus y1 divided by x2 minus x1. And I'm going to use these as my my y2 values, so I'll have 4 and minus 0 and 0 minus -2, or plus 2 in this case, and 4 divided by 2, forget those zeros, is going to be 2. All right, and my y-intercept is at 4, because when x is 0, that's when I have a y-intercept. So I know that my y-intercept is equal to 4, and my slope is equal to 2. So if I put this in the form y equals mx plus b, m is my slope, which was 2, and my y-intercept was 4, and this is what my equation will look like. All right, so what I want you to do is I want you to test the inequality, and I want you to determine what sign this is going to take on. All right, so that will be your little quiz question. Solve this last example.